Okay, so we're actually going to start writing our assembly language programs. So what I do is go to File, New. We'll also click New from here. And we see our file is named RISC-V1, so RISC-V1.asm. I wanted to have a directory that will be saving these files in, so we'll save this. Let's say we learn how to load immediate, so we call this load immediate. And it's a very simple Hello World style program. So I wanted to know two things about RISC-V assembly programs. You'll have different sections. And one of these sections you'll have is a text section. So you could tab or to put text, and under that, want to put .global main. Now we will learn about this, but just type what I'm doing and I'll explain after I run it. I just make sure we have stuff running, right? Then you go to back straight to the left, you'll do main, and we do a tab, we say li a0. So we load an immediate value, the A0, 5. And then we'll say RET, right? So this is what I wanted to type. You'll type this. What I want to pay attention to right now is I want to pay attention to this A5 or the star as well. Oh, this A0, the star is an A0 in the code. So look at A0. This is A0, so this is the name, the A0. So this is where the star X11 and RISC-V, and we see it as zeros, all zeros. So what we do is we'll do run. We'll click assemble and it'll assemble our program, right? And then what I want you to do is you could step through, but for the majority of our cases, especially at this point, you'll see this green button that says run the current program, right? Before we click that, I want you to look at the messages menu, and we'll see assemble, and it says assembling, and you'll see the operation completed successfully. If you had an error, we'll also see any error messages here, right? We also see our data segment, which is our memory values. We'll get to that later. But all I want you to do for now is just click this run the current program button. And if we look at the registers or we look at A0, we see that A0 now has the value 5, right? You'll see, instruction load access error. That's because of how we're doing things, but the point is to understand the load immediate value. So what I want you to take away from this program is that we have different sections. We have a text section that tells the assembler that we are writing code, not data. We also have a global section, and what this does is it makes main, which is the main label we have here. This is called a label. It makes it globally accessible so that RAS know where to start running our program from. Remember, CPU executes stuff sequentially. So to start here, when they reach the global main, it knows that, okay, I start at the main label, and to start sequentially executing instructions from that point. Now, when it goes to main and starts executing instructions, you'll see the first thing it encounters is the first instruction we learn, which is li, load immediate. And what this command does is it tells your CPU that you want to load an immediate value, right? And in this case, immediate value is 5 into register A0. When it runs the program, it will load the value 5 into A0. And you see that reflected on this side. We see that if we look at register A0, it has the value 5. Now, we could have said, let's say, instead we said register A1, right? So we run, we assemble. If we run that, we look at the registers, we see that now A1 has the value 5, right? So you can load immediate almost any registers. As you go about, you'll see that certain registers for certain things, and according to load them, especially in the simulation environment, you'll have different functionalities for system calls and things like that. But I just wanted to know that, this is what we will be doing. The load will be loading a lot of immediates. Now, after it executes this instruction, the CPU run again, and it will go to this line 6, and it has this ret instruction. Now, ret, it means return from subroutine. And all it does is it's called what we call a pseudo instruction, and it lets us know, hey, we reached the end of our program. And on other RISC-V CPUs, what we usually do is return a zero value, right, into the A0 register, which is our return register, if you recall. But to make things simpler, we just say ret, because it's a simple way to practice our assembly. So that's how we're doing, guys. We started at the very beginning, we loading values into registers. And we'll continue and build up from here. And so let's move forward and you'll learn how to do more stuff.